Hello, welcome everybody. I am going to be going through the 2019 course description problem number 2. So I'm going to move some of this stuff out of the way here, and away we go. Number 2, the graph of the figure above shows the graph of f prime, the derivative of a twice differentiable function of f on the closed interval from 0 to 4. The areas are bounded by the graph of f prime and the x-axis are these numbers here, and I filled those in already. And there are horizontal tangent lines at these spots, and I kind of put little gray markings there so you can see that. And then they're giving us an initial condition. So question A, on what open interval contained in 0 to 4 is the graph of f, this is the graph of f prime, both decreasing? So how do I know if f is decreasing? Looking at f prime. F prime must be negative. That's a less than sign. And concave down. So how do I get to know if f is concave down given the graph of f prime? Well, if I'm given the graph of f prime, that's one derivative up to get to a second derivative, because the second derivative must be negative. So how do I know if the second derivative of f is negative? By looking at the first derivative. Well, that's a one derivative leap. So f prime, concave down, must be decreasing. Oh, I really need some stylus and a right-on-able surface for this. All right, so how do I know when f prime is negative? F prime will be negative down here and down here. So which of those points are also decreasing? Those will be the double parts. So we're going to go from 1 to this horizontal tangent line. So 1 to 1.6, because that's that horizontal tangent line. And also this part also fits both criteria. So that's going to be from 3 to this horizontal tangent line. So 3 to 3.5. Okay, so now how do you know that? And then that's why I put my thoughts together up here, because then my clarification for my reason is very clear. F prime is negative, ding. And you have to talk about f prime, so don't say this, f double prime is negative. You have to say f prime is decreasing. You have to speak about what you're given. If you said f double prime is negative, they're not going to give you the reason. Okay, moving on. Part B. Find the absolute minimum value on f. So to find the absolute minimum value, you need to do the candidate test. Most of the time, candidate test is done through a table. They're starting to go away from tables in the last year or two, and they're putting together like just values, and they're showing the work. So I kind of did this problem by minimum value, don't forget it's of f now. I just tried to figure out the points of f. So the first thing I knew on f is 2, 5. So here's my 2, I put together my thoughts, here's my 5. So now, how do I move backwards and get the 1 and to get the 0? Well, let's just think about this for a second. How do I get this 0? Well, the 0 is going to be the spot I know, the 5, added to the backwards movement, because it's at 2, to get back to 0. So how do I get this backwards movement? I can flip these around and think about it. Or if I want to use a little math, I could just go flip the limits of integration and make it negative. So then I have my initial condition of f2 of 5. And I'm going to add that. Well, now I'm subtracting it because I'm going forwards in time. Or you could think of these backward signs that go backwards in time. So that's where you get the positive 2 and negative 6. But you're subtracting that. So then 5 minus negative 4 is going to be 9. And you can think of it going backwards. If you're going up 6 going from 1 to 2, you're going down 6 going from 2 to 1. So how did I get that initial point there? That becomes my 9. And this little graph I like to put together helps to clear up my thoughts. Now, the question is a minimum value, so that's why they don't really show the work for 1. I actually showed the work for 1 here, and I said, well, if I'm going forward 6, if I go backwards, I'm going, if I go forward, I'm going down 6, but if I go backwards, I go up 6. So I actually put this 11 in here from 5 to 11, that's a gaining of 6. So I could actually, if I really wanted to, kind of make my little curve here of this graph. Sorry, this is hard to do here, but you get the picture. This is the other one that's possible minimum, and then the endpoint. So don't forget to check your endpoints and then check your this point here, because this is clearly a minimum. How do I know this is a minimum at 2? Because the f prime changes from negative to positive. So that's my minimum, M there, and then also my minimum check-ins need to be my endpoints. There are some maximums in here at 1, so I don't really need to check that one, and there's also a maximum here at 3. If you checked them, and I kind of did, it's okay to put them in. So how do I get then the answer at the other endpoint? Well, I go from the 2 known value, then I go ahead to 4. So I'm going to be going, this is easy because I'm going in the right direction. You go up 10, down 4. So if I go up 10, I'm at 15, down 4, I'm back at 1. So there we go, I'm at 1. Did they ask for value? They sure did. So you have to give them the value of 1. That is the answer point. Justification, candidate test, and all of these table problems. You could put this absolutely at a table if you wanted to. You could make your X and your F, and you could have a 0, 2, and a 4 here, and then have a 9, 5, and a 1. It really helps to clear up your work with this wording here. So let's look at this point. If you considered -2, because that's when the derivative changes from negative to positive, that certainly gives you that first point. And then answer of 1 along with all of these comparisons is how you get your second point. C, this is a very unique problem. I've never seen anything like this before. It took me a few thoughts to put my, few moments to put my thoughts together on this one. So they want you to evaluate 0 to 4 of f times f prime of x. When I first see this, my gut tells me, hey, that's got to be integration by parts because there's a multiplication. But then how do I do my u? How do I do my dv? I don't know. So I played around with it a little bit more, and I said, hey, this is kind of a classic u sub. If my u is f of x, my du is f prime of x dx. All of this is going to be my du. So if you do it the way I traditionally do it in class, I divide by the f prime, and then I substitute in for my dx, du over f prime, cancel the f primes. But basically, it's the integral of u to u. That's what this is. It's really strange. So how do I do the integral of u du? Right here. I would take u and raise the power and go to 2, and then divide by 2. It's basically u squared over 2. What is u? U is f of x. So they substituted all the way down here, and that was my u here. And then they, instead of doing u, they put f of x back in because they didn't do the limit of integration change. That's it. So then you plug in your 4, and then so you get f of 4 squared minus f of 0 squared, and then these values, so we need a 4 and a 0. Hey, let's go back. 0 and 4, we got my 9 and 1. All of this stuff from part B comes together. And then you go, don't forget to square things. 9 squared is 81. 1 minus 81 is negative 80. Half of negative 80 is negative 40. How do you evaluate the points? The antiderivative of the form this thing. So as long as you have f of x squared, I guess if you did the u, and then you did this, as long as you have your u, that's how you're going to get your first point. And then earn the first point, and okay, so then this constant here, I guess, would be confusing for some students. So you also have to have this 1/2 if students left off the half. But they do have something squared, f of x squared or u squared or whatever. And they have both of those together, you get that second point. And then the answer, of course, is negative 40. So as long as you can work all this out. Very interesting question. This one threw me for a loop because I've never seen anything like it. It's all about problem solving, and you have to persevere through trying something. If you had the time to try integration by parts, you could. I didn't even do that. I don't know if it's possible, but maybe if you get negative 40, I guess, then you could give yourself points, but I don't know. I'm not going to go through that. Part D. G is defined by this. Find G prime. Well, that's pretty simple. It's product rule. So how do I do product rule? I take the first times the derivative of the second. They do it backwards. That's the first. The derivative of f is f prime. That's the second. So the first times the derivative of the second plus the second, f of x, times the derivative of the first. The derivative of x cubed is 3x squared. If I was doing this and writing it out, I would have had these reversed, but addition is commutative, so it doesn't matter. Now you just have to work it all out. So 3 times x, they're asking for 2, so x is 2, so 3 times 2 squared. F of 2, here we go again. How do I find f of 2? It was given to me, and I also cleared it up in that spot. It's a 5. Then how do I find f prime of 2? Well, here's the graph of f prime. What's the value at 2? It's a 0. Putting this all together, you should get 60. You don't have to simplify since it's no calculator. You certainly can't leave it like this, but either one of these double underlined answers are fine. If you knew to use product rule and you did it correctly right here, that's where you get your first point. But then some students just don't know, hey, where do I get these values from? I'm confused. They wouldn't get the second point, but I have confidence that you could have done that one. There you go. That is course description 2019, a very strange problem, but certainly doable.